Here is an example. In this example, he's asking us to find the output voltage V naught. So this is nothing but a summing amplifier, because we are going to sum up three voltages. Okay. Anyway, always remember, take this as V2 plus and V1 as, inverted terminal. It's non-inverted terminal. Okay, V1 is always inverted terminal, V2 is always non-inverted terminal. What is V2? Here we can see this is grounded, so V2 must be 0. So here V2 equal to 0, and we also know V2 equal to V1 equal, these two are equal, so this must be equal to 0 in this case. Let me take out that. So we know that V2 must be equal to V1. Another important point we need to remember, there is no current entering into the operational amplifier here. Now this is a summing amplifier, our goal is finding V naught. Okay, at V1 apply KCL. Okay, if apply KCL, I'm going to take this current as IA, IB, IC, and this current as IF. This resistance, I'm going to take that as RF. Okay, so if I apply KCL at V1, IA plus IB plus IC equal to IF. What is IA? So the voltage at this point must be 10 volts, because the voltage here is 0 volt, right? So VA minus 0 must be equal to VAB, which is 10 volts. So here it must be 5 volt, here it must be 20 volt. Okay, so IA, I can take this as 10 minus V1 over 5K plus IB 5 minus V1 over 30K plus IC is nothing but 20 minus V1 over 10K equal to IF must be equal to V1 minus V0 over 60K. Okay, now to eliminate the denominator, I'm going to multiply this with the 60K. By the way, in the operational amplifier, most of the time you will see kilo ohms. Okay, these are electronic circuits, usually they can handle in milliampere, microampere, so it's always in kilo ohms. Now if I multiply this with 60K, I'm going to do it offline. Okay, I have another idea. I got V1, I know V1 equal to 0, so I'm going to substitute that. So 10 over 5K plus 5 over 30K plus 20 over 10K equal to minus V0 over 60K. Now I'm going to bring V0, 60K to the other side. I will end up with minus V0 equal to 60 or 600K over 5K plus 5 times 60K over 30K plus 20 times 60K over 10K. So K get cancelled out here. This is 120 plus this is 10 plus 120. Okay, so here V0 equal to minus 250 volt. That's the output voltage. Now I think I mentioned this in the previous video. Here I have the supply voltage, power supply V plus and V minus. Usually these power supplies are rated, they're going to be rated at plus 15 and minus 15. So most probably your output is going to be clipped at 15 volts. But since I didn't give you the power rating of that amplifier, I'm going to leave it here. Okay, so my output voltage is equal to minus 250 volt. I'm going to solve next example in the same video. Okay, another important point I forgot to mention here. See, our input is given to the inverted terminal, so your output is going to be inverted. So that's the reason you have negative number there. Now here is the next example. In this next example, this is also inverted amplifier. at the same time it is inverted, so output is going to be inverted, and it's a summing amplifier. He gave you V naught value, he's asking us what is V2 in this case. Okay, so we always take this value as V2, this value as V1, and remember current entering here is 0, current entering is also 0. All we know, V1 equal to V2 equal to 0 volts. Okay, that's what we know. Now apply KCL at V1 to find V2. Okay, apply KCL at V1. So I'm assuming every current is going in. I'm going to take this as I1, I2, I3, and this current as IF. IF is feedback current. Okay, and I1 plus I2 plus I3 equal to IF. So I1 equal to 2 minus, I know V1 is 0, so I'm going to put 0. 2 minus 0 over 10k plus I2 is, I don't know what is V2, V2 minus 0 over 20k plus V3 is minus 1 over 50k equal to IF is 0 minus of minus 16.5 over 50k. Okay, I'm going to multiply on both sides by using 50k. So it's going to be 5 times 2, this is going to be 10 plus 2.5 V2 minus 1 equal to 16.5. Okay, I will end up with 2.5 V2 equal to, this is 9, so 16.5 minus 9, I'll end up with 7.5 volt. V2 must be 7.5 divided by 2.5. This value must be 3 volt. V2 must be 3 volt. Okay, so this is a summing amplifier. So all you need to know how to apply KCL or KVL, and you need to remember this point, V1 must be equal to V2 all the time, and current entering here equal to 0. I'm going to solve one more example in this video. Okay, here is another example. This is little bit interesting example. Here he labeled them V2, V1, V2, V1, but I'm going to use the numbers. Here there is a 10 volts, excuse me, 5 volt there, 5 volt, 10 volt, and the resistance here is 5 kilo ohm, resistance here is 2 kilo ohm, 2 kilo ohm, 8 kilo ohm. Okay, and Rx is 2 kilo ohm. So first thing we need to find what is the voltage at this point. Okay, the voltage at that point must be okay. So to avoid confusion, assuming these are the small voltages, but here I have the bigger voltage. Now our first goal is always we want to find V2. Okay, what is V2? In the previous examples we have V2 is always grounded, but here it is not grounded because I have a voltage. So this indicates that the voltage at this node is 10 volts. Okay, and I have a closed path. Through this closed path there is some current passing through it. Okay, what is that current? Let me take that as Ix. What is Ix in this case? Ix equal to 10 over 8 plus 2, so that's 1 milliampere. 8 plus 2k. Okay, that's 1 milliampere. So 1 milliampere current is passing through this. So V2 equal to, I can say 1 milliampere times 2 kilo ohms, because the voltage here must be V2. That value is 2 volts. Okay, that is the important point. Okay. So I found V2 equal to 2 volt. Now we know that V2 is always equal to V1. That value is 2 volts in this case. So I have 2 volt at V1. Excuse me. So I have 2 volt at V1. V1 equal to V2 equal to 2 volt. Now at V1 apply KCL. Okay, I'm applying KCL at this point. Okay, I'm going to take this as I1, I2, I3. Only 3 currents are coming over there, and as usual I'm going to take this as IF. So I1 plus I2 plus I3 equal to IF. What is I1? I1 is nothing but 10 minus V1. So the voltage at this point is 10 volts. Voltage at this point, these two are the same, or these four are the same points, same node. So the voltage at that on this red line anywhere is V1, which is 2 volts. Okay, so 10 minus V1 over 5k plus I2. I2 is 5 minus V1 over 2k plus 5 minus V1 over 2k equal to V1 minus V0 over 20k. Okay, I'm going to substitute V1 equal to 2 in this equation. So if I substitute 2 here, 10 minus 2, which is 8 over 5k plus 3 over 2k. Okay, 8 over 5k plus 2 over 2k. Sorry, 3 over 2k. 3 over 2k plus 5 minus 2, 3 over 2k equal to 2 minus V0 over 20k. So to eliminate the denominator, I'm going to bring this 20k to the other side. So once I bring, I'm going to multiply this with 20k on both sides to eliminate the denominator. So it's going to be 4 times 8, 32 plus 30 plus 30 equal to 2 minus V0. Okay, so V0 equal to minus 90 volt. As usual, since he didn't give us the V plus and V minus here power sources, I'm going to say my V0 is minus 90 volts. But as usual, if he gave you V plus V minus value, it is going to clip at that voltage. Okay, I'll stop this video. I'll continue solving more examples in the next video. Thank you.